Hi gang, I'm going to introduce you to the wonderful world of step functions today. So this function that you see here with the double brackets is an example of a step function. It's also sometimes referred to as the for function or the greatest integer function. So the way this works is if you make an XY table back, anytime I put in a number, I'm always going to round down. That's why it's called the greatest integer function. So for example, if I put in 0.5, that would round down to 0. And if I put in 0.7, that would round down to 0. Even if I put in 0.99, that would round down to 0. The minute I get to 1 or 1.1, that rounds down to 1. And like 1.4 rounds down to 1. And 1.9 rounds down to 1. But the minute I get to 2, 2.2, that would round down to 2, and so on. So you start to see the pattern. One place to be careful, guys, when you get to negative. So negative 0.5. Negative 0.5 would round down to negative 1. And negative 1.5 would round down to negative 2. So if I wanted to graph this, the way this would work would be anything between 0 and 1. So anything between here on the graph and here would round down to 0. Now notice that at 1, I put an open circle because 0.99, when you get really, really close to 1, like 0.99, it's going to round down to 0. But the minute you get to 1, it rounds down to 1. So it jumps up. So then anything between 1 and 2, including 1, so 1 all the way up to 2, but not including 2, because the minute you get to 2, it rounds down to 2. But 1.99999 would still round down to 1. So you get that step. And then anything between 2 and 3 would look like that. And anything between 3 and 4 would look like that. And then on this direction, anything between negative 1 and 0 negative 1 would be negative 1. But then all the way down close to 0 would be an open circle. And so on. So you start to see the series of steps. Hence the name. This is called a step function. So this is one of the basic functions that you need to have memorized. Just like it's like an x squared or a square root of x or an absolute value of x, the step function, the greatest integer function, is one you should memorize and know what it looks like. Because if you know what it looks like, then we can get to one problem like this. And this is going to follow all the same patterns as the transformations of the other ones. So here's your basic step. So here's the way I think of it. This is your basic step, right? I'm going to put it in red. Oh, what happened? So this is your function that you will memorize, and it looks something like that. Right? So there's your basic function. When you have an x minus 2 on the inside of the function, of the step function, what's going to wind up happening is it's going to wind up moving everything over 2 spaces. So to go about graphing this, if I plug in 2, 2 minus 2 would be 0, so that would be a dot right there. And if I plug in 3, 3 minus 2 would be 1, so I'd put a dot right there. And then if I plug in 4, 4 minus 2 would be 2, so I'd put a dot right there. And then you would just need to remember what this looks like so that you could draw your steps. And here is your step function. So remember, the red one is the basic function. That's the one you want to remember. The basic steps. They go from 0 to 1, from 1 to 2, from 2 to 3, and so on. And then the blue one is the transformed function. Everything got moved over 2 spaces. And what about this one, 1/2 x? So think about it this way. I'm going to plug in 0. 1/2 times 0 is 0. So I'm going to get a dot right there. If I plug in 1 inside the absolute value, it would become 1/2, or not the absolute value, the step function times 1, which would just be 1/2. So if I plug in 1, I get 1/2. And if I were to do 2, 1/2 times 2, that would be 1. So 2 is going to give me a 1. And 3 would give me a 1.5, and 4 would give me a 2. And so what I have here is I have steps that look like this. So the steps have shrunk. So that's what a transformation does on the outside, is it compresses all the steps and it makes them much narrower. Right? So instead of being as big as these steps were, see how big those steps were, the 1/2 on the outside compresses them all. All right, so one last one. So first thing I'm going to do is I'm going to put in my basic function so that I remember what it looks like. So the basic function looks like this. Solid dot and over, and solid dot and over. So now I'm going to do the transformed function. Change the color so we can see that. So the -3 on the outside, what it does, remember, is it moves it up and down. If I put in 0, I would get 0 minus 3, which would be -3. So it's going to come down here. And if I put in 1, I'd get 1 minus 3, which would be -2. And if I put in 2, I get 2 minus 3, which would be -1. And if I put in 3, I get 3 minus 3, which would be 0. So I can see that I'm laying the foundation for my steps. And so then here's the transformed function. As long as you know the basic function, then you should be able to graph the transform function. So now I'm going to let you try some.